Hello, I'm A. Garke Sai from First BTech First Semester CAD A section, Srinivasa Ramanujan Institute of Technology. Today my video presentation topic is from the subject Basic Electrical and Electronics Engineering, and the topic is Combinational Circuits. Combinational Circuits. Introduction. Combinational circuit, also called as combinational logic circuit, is a digital electronic circuit whose output is determined by present input's value only. No memory elements involved. Used for arithmetic and logical operators, data transmission, and also for converters. Here we have a flowchart of combinational logic circuit, data transmission, arithmetic and logical operations, converters. In data transmission, encoders, decoders, multiplexers, demultiplexers takes place. In arithmetic and logical operations, adders, subtractors, comparators, PLDs takes place. In converters, BCD, binary, and 7 segments are there. Characteristics. No memory element. They do not store information. Composed of logic gates built using basic gates like AND, OR, NAND, etc. Fast operation. Output is obtained after the propagation delay of the logic gates. No clock signal needed. Unlike sequential circuits, combinational circuits do not require a clock. Basic logic gates. Generally, we have some basic logic gates like AND, OR, NOT. Universal gates like NAND, NOR, and XOR, like and exclusive or XNOR, exclusive NOR. Logic gates are used in combinational circuits. Binary adders. A binary adder is a combinational circuit that performs the addition of binary digits or bits. Depending on the design and configuration, there are two types of binary adders, namely half adder and full adder. Half adder. The half adder is a combinational logic circuit with two inputs and two outputs. The half adder circuit is designed to add two single bit binary numbers A and B. It is the basic building block for the addition of two single bit numbers. This circuit has two outputs, namely sum and carry. Adds two bits. Outputs sum, carry. Sum is equals to A XOR B. Carry A and B. Full adder. The full adder is a designed to overcome the drawback of a half adder, which is the ability to add only two bits. Therefore, the full adder is a three input and two output combinational circuit where the inputs are two 1-bit numbers A and B and a carry C from the previous addition. The output are sum and carry output. Adds A, B and C is intake. The outputs sum and C out. Sum is equals to A XOR B XOR C in. C out is equals to AB plus BC in plus AC in. Addition. Multiplexers. Mux. A multiplexer is a special type of combinational logic circuit. It consists of N data input lines, one output, and M select lines. For a multiplexer, N is equals to 2 power M. A multiplexer is a digital circuit that selects one of the N data inputs and routes it to the output line. The selection of one of the N data inputs is done by the select lines. Depending on the digital code applied at the select lines, one out of N data inputs is selected and transmitted to the output line. Depending on the number of input lines, there can be several types of multiplexers. Some common types of multiplexers include 2 is to 1 multiplexer, 4 is to 1 multiplexer, 16 is to 1 multiplexer, and 32 is to 1 multiplexer. Decoders. A decoder is a combinational circuit that converts a binary code into a normal word like a decimal digit. A decoder typically consists of n input lines and m output lines, where the m is equals to 2 power n. Decoders are widely used in display drivers, data distribution systems, etc. Some of the commonly used types of data decoders are 2 to 4 decoder, 3 to 8 decoder, 4 to 16 decoder, BCD to 7 segment decoder, etc. Applications of combinational circuit. Combinational circuits are the fundamental building blocks in various digital devices and systems. They are widely used in several digital devices in which combinational circuits are used. Microprocessor and microcontrollers, digital computers, calculators, digital communication systems, keyboards, smartphones, and digital watches, etc. Limitations of combinational circuits. Combinational circuits have several advantages such as fast operational speed, simpler circuit, predictable operation, etc. However, they do have several limitations too, some of which are listed below. Combinational circuits do not have any memory element. They are incapable to store history of circuit operation. Combinational circuits cannot be used to implement certain highly complex logic functions. At large scale, combinational circuits have several design complexities that can result in poor performance and inefficient resource utilization. Conclusion. A combinational circuit is a key component in various digital devices and systems. It can be defined as an interconnected system of digital components whose output depends only on the present states of inputs, and it does not depend on the past input and output values.